Okay, welcome to lesson 71 to 24, two famous triangles. Okay, so the first angle we're going to start with is a 45-degree triangle. So if one side is 45 degrees, what's the other side? So we know from geometry that a triangle, all the angles, so if I draw this for angles, all the angles in a triangle equals 180 degrees. So now, in a right triangle, one side is 90. So 180 minus 90 leaves us with 90 for the other two sides. If we take away 45, we're left with 45. So we call this a 45, 45, 90 right triangle. So 45, 45. Now, what's special about a 45? If the angles are the same, then the lengths of the side have to be the same. So if the adjacent angle is 1, length is 1, the opposite length has to be 1. And how does it work? The radius or the hypotenuse is equal to the root of 2. How do we get that? 1 squared plus 1 squared equals r squared, where x plus y. If we change Pythagorean's theorems to x, y, and hypotenuse, or r, which is radius, you can use RH. It doesn't make a difference. We stick in 1 and 1. We get 1 plus 1 equals r squared. 2 equals r squared. And to get rid of an r squared, we take the square root of both sides. And so r equals the square root of 2. And that's how we get the square root of 2. And then this becomes a unit length. Unit meaning the measurement is 1. Our other famous triangle is a 30, 60, 90 triangle. So how does a 30, 60, 90 triangle work? Okay, so in a 30, 60, 90 triangle, opposite the 30, this length is 1. So how does this work? The 30 opposite to 30 is 1/2 the hypotenuse. And then the 60-degree leg is always not equals 1/2 times the hypotenuse. Opposite to 60 is root 3 times the short leg. So we're going to do some basic math with these formulas for these two angles. So this is a 30, 60, 90 degree right triangle. So that little L means right angle in geometry. Okay, so now from the previous lesson, 7123, evaluate all trig functions of a 45-degree angle. So we need the sine. Okay, so the sine, if we just look at it, is 1 over root 2. But what we can't do is leave a radical in the bottom. So I have to get rid of the radical in the bottom by multiplying by root 2 over 2, which gives me root 2 over 2. Because a root times a root, they cancel out, and I'm left with what's under there. So the cosine is the same length as 1 over root 2, but I have to get rid of root 2 over, I have to get rid of the radical in the bottom, and that gives me root 2 over 2. Now for the tangent. The tangent is the x divided by the y. So basically what I have, if the numerator, if that's the x, the sine is the y, and y over the hypotenuse is r. If that's the x and that's the r, you have 1 over 1, which equals 1. Now for the other three, cosine All the co's go with the non-co's. So sine does not have a co in front of it. So what's opposite the sine is the cosecant. CSC is called the cosecant. And what you do is you take and flip the sign upside down, which leaves us with root 2. The cosine goes with the secant, SEC, which is the same thing, root 2 over 1, which equals root 2. And then the tangent goes with the cotangent, which equals 1 over 1 flipped down, which is still 1. So a co goes with a non-co. A co goes with a non-co. A co goes with a non-co. That's how they work down for all 6 angles. Okay, so now let's evaluate the trig functions of a 30-degree angle. So we're going to start with the sine. I know it says sin, but it's actually the sine. The word is sine. It's the opposite over the hypotenuse, which is 1 over 2. If you look at the triangles from above that we looked at, I should have put the angle in there. I'm sorry, I forgot to put the angle in there. The cosine of a 30-degree angle is root 3 over 2. The tangent is the y, which is 1, over the x, which is root 3. But we have to multiply top and bottom by root 3. So we get root 3 over 3. So that's a 3 up top. Sorry, that looks so messy. So root 3 over 3. So now the tangent goes with the cotangent. And we just take and flip that upside down. So that's 3 over root 3, but we can't leave a radical in the bottom, which gives us 3 root 3 over 3. The 3's cancel out, and we're left with root 3. Always simplify your fractions. The cosine goes with the secant, which is 2 over root 3, because we flipped the cosine upside down. Now we have to multiply by root 3 over root 3, which gives us 2 root 3 over 3. And now finally, the secant goes with the cosecant, which gives us 2 over 1, which equals 2. Okay, now let's look at another type of example. Let theta be an acute angle such that sine of theta is 5 over 6. Evaluate the other trig functions. Okay, so we're given the sine is 5 over 6. So let's write that down first. So the sine of theta equals 5 over 6. That means the cosecant, because the sine and the cosecant are inverse or reciprocal functions. Now we got to find the other ones. So the first thing we got to do is find x. And we know that x from x squared plus y squared equals r squared plus y squared equals r squared, where x is the x-axis, y is the y-axis, and r is the radius. X squared equals r squared minus y squared. X equals the square root of r squared minus y squared. X equals the square root of 36 minus 25, which equals the square root of 11. And I'm going to stop right there because 11 is not a perfect number, and the answer is irrational. So we're going to leave it exact as root 11. So now that we have the x side, we can now do the cosine. The cosine is root 11 over 6. The tangent is 5 over root 11, but we can't leave that, which equals 5 root 11 over 11. And the cosine is opposite of the secant, so that gives us 6 over root 11, but we can't leave it like that. which is 6 root 11 over 11, and then the cotangent goes with the tangent is root 11 over 5. And that's how we evaluate all 6 trig functions. And we leave our answers exact. No decimals, unless we're asked for a decimal. And then we evaluate it at the end. Do not evaluate in the middle, round off, and then keep calculating. You're going to be off by a couple tenths. And I don't know the accuracy of the machine or program you're working with. So we'll talk about that. I talked about that in calculator tricks when we earlier when we talked about radicals. Now go do some practice problems.